Good evening. Welcome, everyone, to Moon-topia. This is Moon-topia, lucky number 7. We're going to be looking at the Himalia group tonight. If anyone's ever heard of those, if you haven't, that's okay. That's why we're here. This is our monthly tour of some of our solar system's fabulous satellites. I'm Irene Pease here with the Amateur Astronomers Association out of New York City. You can find AAA at AAA.org. You can follow us on the social media things at AAADOTORG. We try to have a lot of stuff going on for our members. We have a happy hour coming up for our members. Looking forward to that. If you didn't get your emails, check the calendar. That's members only. We have classes for our members. We have free public lectures, one just last week and the next one coming up in early March. So check us out. Check out our calendar. Check out the website for fun things around New York City and beyond with in the world of astronomy. So tonight, as usual, we're going to be using visuals from Stellarium, which you can find at stellarium.org. We'll pop over to that in a minute. And in the background right now, you see Open Space, which you can find and download for free at openspaceproject.com. And we're mostly going to be flying around in open space. So we'll be back for lots of that in just a little bit. But to just kind of get started off, we want to see, first of all, what's up in the night sky. And actually going to be looking a little bit more at the morning sky. But I'm going to go ahead and flip on over to Stellarium for some of that. So off to Stellarium. And so here we are at now. Happy Monday, if you celebrate Mondays. This is kind of the night sky as seen from New York City. Artificially darker. Our New York City skies aren't quite this dark on most nights, especially tonight when it's cloudy. We're not really seeing all this stuff. Exciting things in the sky tonight. Obviously, the moon and Mars are always gorgeous. We're not looking at our moon in the show tonight, but we'll be looking at, as I mentioned, some Jovian moons. So where in the world is Jove? Well, it's not so visible. So if you're a morning person, congratulations. Not much to see in the mornings these days because the sun comes up at this kind of steep angle relative to the horizon. So you can see Saturn trying to poke above the mountains of Brooklyn here. Yes, we have a mountain in Brooklyn. It's called Mount Prospect. But anyway, I digress. So if there weren't mountains there, or if you really just wait another couple weeks, I'm going to fast forward using our nifty time machine here in Stellarium. In early March, you stand a little bit better chance of seeing some really magnificent planets in the morning sky. So we'll kind of just set this for 6-ish. Early March, and there we can see a nice little gathering in the early mornings. So a couple planets as well as the moon that kind of first week or so of March. And of course, among those planets, we have Mercury. So you want to get up there pretty early. If I fast forward a little bit more, or we can cheat and just kind of turn off the atmosphere if everyone's willing to hold their breath for a few moments here. We can see the planets that will be out in the morning. We have Mercury, Jupiter, Saturn, the moon, and I believe Venus was in there not too long ago. Venus is hiding somewhere. But tonight we really wanted to look at some moons of Jupiter. So I'm sure a lot of folks here tuning in are familiar with some of the moons of Jupiter. If you could go ahead and list them off, which are the moons of Jupiter, thinking, and see if you can rattle those off before I zoom in. That's one of the fun things that we like to show people in our telescopes when we get to do sidewalk astronomy, which hopefully we'll get to do again at some point safely. In the meantime, here you have Stellarium, and you can download it and play with it on your own as well. So if you see Jupiter in telescope or binoculars, you can catch the largest moons. And I'm just going to pause. I'm going to pause time here so Jupiter doesn't run away from me. So we have Io, yes, Europa. Those are some of the moons I'm seeing listed in the chat. We have two more, and they're starting to come up here now. So we have Callisto, and some of you may have already have mentioned in your minds Ganymede. So those are the four largest the largest moons, which we call the Galilean moons. And I made up a mnemonic all by myself earlier today um, to help myself remember the 8 largest moons. So these are the 4 that we can see in binoculars and telescope. We call them the Galilean moons because Galileo was the first one to really sketch them and publish those as he saw them in his early telescope. He didn't call them the Galilean moons, he called them the Medici stars. He didn't name them after himself, certainly not using his first name. That's so weird. But here we are looking at the largest of the Jovian moons, the largest of Jupiter's moons. So my mnemonic that I am using to remember the 8 largest moons, and you can write this down if you really want. You're all welcome to use it. I'm going with grilled cheese in each hand and extra tomato. So those first 4, of course, are the Galileans, right? So grilled, here's our grilled, cheese in each, and that's as far as we get. So for the hand, we're not actually going to see the hand in here. If I zoom in really far, this worked earlier, you can see the and. So it was grilled cheese in each hand and extra tomato. So you can see the and, Almathea is in here, and Phoebe, that's the tomato, is also in here. So those are, ignore that, pretend that's not there. So those are the some of the largest moons in the top 8. Almathea is actually the 6th largest, but it shows up as the 5th sometimes because it's brighter than the 5th largest moon. That's the hand. And also because the hand, that's H for the Himalia group that we're going to be looking at tonight. Those moons in the Himalia group, they're not close in. So if you're looking really close to Jupiter, you're not even looking in the right part of the sky unless they happen to be along the line of sight. The Himalia group, they're really far out. So literally far out. So we're going to pop on over to open space so we can see where those are in the Jovian system and not really look at pretty pictures because we don't actually have pretty pictures of them, but I have some other things to look at in lieu of pretty pictures. So there's Jupiter. Try to catch it in the morning sky starting in early March. And good luck with that. We'll be back in March to check on those skies again. But for now, on over to the open space. And here we are. So again, open space, you can download that for free, fly around in 3D. It's kind of fun, kind of heavy on the processing, so it helps to have like a gaming computer or something. Ooh. And you can literally just go for a spin. So all of the data in here is real data, actually collected by various surveys and missions and whatnot. If you want to learn all about current missions, we have a class for that. It's kind of coming to a close in the next few weeks. But off in the background there, we can see that's our target. So the little swarm there around Jupiter is where we're going to head next up. So hop over to Jupiter. And off we go. So yeah, so we had grilled cheese in each hand and extra tomato. So the grilled cheese in each we've got. The and we're not really going to talk about tonight, and the tomato we're not really going to talk about tonight. That was Thebe. I think Thebe actually came up in a previous Moon-topia. That may have been the Choose Your Own Adventure. But we're going to talk about the hand and the extra. Hand extra. So hand, that's Himalia for the Himalia group. So Himalia is the 5th largest moon in the Jovian system, but it's much smaller than the 4th largest. So remember the 4th largest, that's each that's Europa. So I want to say it's 1/20th. Yeah, it's 1/20th the size of Europa. So much, much smaller. And it's just a little bit bigger than Almathea. Um, but again, Almathea is a lot brighter. So all of these moons here, all 7, so start counting. See if you can count 7 highlighted here in the Himalia group. All 7 are very, very dark, and even Himalaya is pretty small, already quite small compared to the Galilean moons. And Himalaya is by far the largest of this group. So we're going to go all the way down to just a few kilometers across. So starting with gigantoid Himalaya, which is around 140, really it's kind of oblong. So we're going to say kind of 150 to 120 kilometers in diameter along various diameters. It's one of the closer moons from this group. So if you can count, see which one looks closest. And they're kind of like a mishmash here. There's a reason for that. I'll get to that. But yeah, so if you've counted up all 7, then you're seeing things, because there's only 5 of the Himalaya group shown here. And there's a reason for that. Yeah. So let's kind of dig in here. So we'll go ahead and focus in on Himalaya, see where that is, see if we can pick it out in here. Himalaya. There she is. Zoom right in. So Himalaya is one of the largest moons in our solar system that we don't have nice, pretty pictures for. Again, it's very dark. It wasn't discovered until early 1900s, 1904. It was discovered at a Lick Observatory outside of San Jose, California. So as we're coming in here, there should be, yeah, kind of an oblong blob. I think it's oblong. Pretty sure it's oblong. So you can see this kind of long blob here. And I'm going to go ahead and brighten a few things. I don't know if I can make it actually artificially bright. Yeah. Okay. No, that looks weird. All right. So we're just going to leave it kind of shaded. So it's a little ways out from Jupiter, and I am going to artificially brighten Jupiter. So instead of having shadow on Jupiter, we'll take that away so we can swing around and see just how far away it is from Jupiter. These are pretty far out there. So discovered in 1904, Lick Observatory. It's actually small enough that it's not tidally locked. So most of the large moons, if you've been listening to Moon-topias, you've been hearing me say that all these large moons are tidally locked, meaning that the same side of the moon is always facing the host planet. Well, that's not true for all these little boogers out here. So this one takes the better part of a year, about 250 days to orbit around Jupiter, but it rotates on its axis in less than 8 hours. So you can see how far out from Jupiter it is. There's the teeny tiny Jupiter. So really in the thumbnail that I used, Jupiter was enlarged artificially. So we're way out there, out in getting towards the outer parts of the Jovian system. And again, we don't really have very good images. The best images that we have of this are actually from the Cassini and New Horizons missions that went by in 2000 and 2007 respectively. So the fabulous Cassini image, I believe I have in here. Wow. Remember what Pluto used to look like? Yeah, okay. So that's it. This is kind of showing which parts are light. So really we think there's more back here, but it's dark, and there's like the little pinpoint like in the star field. So this was the Cassini image. Thanks Cassini for that. So just a few pixels, because we didn't get very close because it's, pretty far out there. But it's from this group of asteroids that may be either C-type or D-type, which basically means they're really dark. So C-type asteroids, we're actually going to move out a little bit and take a quick look at the asteroid belts to see if we can put some of this in context. Because again, I don't really have pretty pictures of the moons because they're really dark and hard to see. So a lot of people may be familiar with the asteroid belt, which is mainly between the orbits of Mars and Jupiter in our solar system. And if I turn on just a bit of those, we have several different sections of the asteroid belt, and this is the main outer belt. And careful not to crash my computer with this because it's a lot of data. So actually I'm going to turn those off and move out just a little bit further so you get a little bit more context of the solar system in there. Right. So all these blue dots, they're in here. This is again the outer belt, and you can see some of them are definitely out towards the region where Jupiter is orbiting. Has it cleared its orbit? I'm not even going to get into that. Let's not fight about that tonight. Let's just take it for granted that, yeah, some of these outer belt asteroids kind of cross Jupiter's orbit. Fine. So they could get captured by Jupiter. And so we think that's what happened to this group of moons, that they actually came from a captured asteroid, something maybe got too close to Jupiter, and it got maybe a little bit ripped apart. So probably everything in this group, in the Himalia group, are all kind of remnants from the same common body. So carbonaceous, meaning they have a lot of carbon, they're very, very dark, they're very not reflective. That's actually about 75% of all the asteroids in the main belt. And a lot of those tend to be, further out. The D types are even darker. They have silicates, carbon, maybe some water ice, but also very, very not reflective. And Phobos, for example, I'm taking a break. I'm taking a whole 30-minute break from Mars tonight to not do Mars this week. But Phobos, one of Mars's moons, might be from a D-class asteroid. So if you're familiar with Phobos, it's kind of darker, not super bright and reflective, not as much as Deimos. So that's kind of what we're dealing with. That's why these are so hard to see. 1, they're not big. 2, they're very, very dark. And then 3, they're kind of a mess. Like they're swirling all over here. So again, because they're so small and because they're getting perturbed by Jupiter and by the sun, those are the 2 most massive bodies in our solar system, the orbits are constantly changing. So they're constantly getting perturbed. So we do have the SPICE data set that NASA kind of puts out, so we have some idea of like where these things are and when. But yeah, their orbits are always changing, so that's why they're a little bit of a mess. And there might be another reason too, but I'll get to that in a bit. So in spite of being kind of a mess, they're all orbiting at about the same distance. It might not quite look like it from these, but they're all orbiting at about the same distance from Jupiter and similar compositions. So that's why we think they're, probably all related. So again, Himalia is just the largest one. We can go into the E. That was the extra. So remember our grilled cheese in each hand and extra tomato. So the extra, that's Ellaria, which was discovered 1904. Same telescope, same guy, Lick Observatory. So let's dial into Ellaria. So Ellaria and the next one, Lidia, those are actually orbiting at pretty much the same distance as each other. So they're a little further out than Himalia, but just coming over to Ellaria, and then we'll kind of take a look back at Jupiter. So this guy, Charles Dillon Peer, he was an astronomer at Lick Observatory in California. And at some point, he actually went down to South America to run or help with a telescope down in Argentina. And why would I mention that? Well, we're going to come full circle, or full orbit, as I like to say, in a little while with that. So remember, note to self, South American telescopes. So here we are. Ellaria, that's the second largest one in the group, but that one's already much, much smaller. So again, Himalia, that was about 140-ish kilometers across. This one's only 80. So it's like half the size of Himalia. So we're already getting down to some teeny weeny little moons, so to speak. Um, the and this one actually, the Himalaya and Ellaria, used to be known as Jupiter 6 and Jupiter 7, because again the um, Am- Amalthea, that was brighter, so that one was discovered first. That was Jupiter 5 because it was discovered before these two. So then these were labeled 6 and 7 for several decades until like middle of the last century when they gave them the fancy names of all the Greek nymphs. We don't have to get into that. But yeah, so they used to have like these Roman numeral names based on the order of their discovery. So Leucidia, that was actually once upon a time Jupiter 10. We can just pop over there for a moment. Way over here. So other side of Jupiter at the moment, but still about the same distance as Ellaria. A little bit smaller. This one's about half the size of Leucidia, so we're getting down to 40 kilometers across. So we're getting down there. So we started at 140. Whoops, that's a bit large. 140 down to 80. Now we're at 40. And then the next one down, Lidia, that's only 21. So we're gonna go half this size again. All right. So looking back towards Jupiter, we're still a little bit further away. If we pop down to Lidia, Lidia is the closest in this group, closest to Jupiter, but getting really small, 21, and it's still not the smallest one. So again, try to imagine finding these moons, these satellites that are only tens of kilometers across, and very dark because they're like these Class C, Class D type asteroid objects. Not asteroids any longer. Now they're satellites of Jupiter, but still, that's where we think they came from. So, so again, I mentioned Ellaria was found at Lick. Leucidia was found at Mount Wilson in the 30s. Lidia at Mount Palomar in the 70s. So we're all a bunch of California observatories finding these moons of Jupiter. Kind of amazing. So that was all ground-based observation, really, which is kind of impressive. So not a whole lot of follow-up, even with the successive missions, just because they're so small and, again, so far from Jupiter and so dark. So basically finding these things by looking night after night and seeing if something blinked or if something moved just a little bit. So pretty tricky. The last one that's actually listed here, because like I said, there's only 5 shown here in open space. That last one, Dia, that is actually the furthest one out, and that's only, wait for it, 4 kilometers across. So we went from 140, 80, 40, 20. We're just skipping the 10. Just we're going straight to 4, just 4 kilometers across for little dinky Dia. Just kidding, Dia. It's not your fault. So Dia, way out here. And again, no pretty pictures. But that's where Dia would be in the Jovian system. So 4 kilometers across. Amazing that we could find something. And there's still 2 more that are even just a little bit smaller. All right. So how did we even get these others? So Dia, again, that was only discovered in 2000. So that was kind of the day back in the time. And even now, I guess, they keep finding more moons around Jupiter and Saturn. And so I just kind of stopped trying to keep track. I'm like, maybe a 4th grader knows how many moons these all have, but I don't, because I'm not, watching the news every single day to see when they find more moons. Okay. So, just a couple years ago, there was another big Jupiter moon find. Some of you might recall. Um, and not using a telescope in Hawaii for once. And actually, this one, even Dia, this one was found using the CFHT, the Canada France Hawaii telescope, on Mauna Kea, on Big Island of Hawaii. So, so this one we step out a little bit, so we're no longer just California found asteroids, but we're getting out into the ocean. And the last batch, the last two that I don't have in here, Ursa and Pandia, those are just as small, basically, as Dia. Ursa, 3 kilometers across, Pandia, 3 kilometers across, so just slightly smaller than our 4 kilometer Dia. And those were found by a group using some other telescopes, including some telescopes in South America. um, and this group was looking actually not for moons of Jupiter. They were looking out. So we're going to zoom out, out, out of our solar system again for some perspective. They were looking past Jupiter, past all the planets, really, to this other group of kind of asteroid-like objects, the Kuiper Belt. So these are trans-Neptunian objects. They're basically out in the Kuiper Belt. They're past the orbit of Neptune. Most of them are out past Pluto. So this group was trying to find these not ridiculously tiny, but very, very, very distant and not ridiculously huge bodies far, far out there. So they were using methods that would detect relatively faint things. And when I say relatively faint, we're talking over 20 magnitude. So for those of you who know magnitudes, the moons that happened to be in their field of view as they were looking from Earth out towards the outer parts of our solar system, out towards the Kuiper Belt, they happened to catch a few of these distant moons of Jupiter in the field of view. And so those two were Ursa and Pandia, these tiny 3 kilometer moons. And so kind of full circle with all our observatories from California to Hawaii and then back to South America. So some telescopes in Chile that they used in that survey. Again, just happened to find 12 Jovian moons total. And so that was a group led by Scott Shepard of Carnegie Institute for Science. And some of you might recognize that name. If you do, it's because Scott Shepard, even more recently, same guy, maybe different group, maybe same researchers, found 20 moons of Saturn to bring Saturn's total to 82. So that was just like 2019, I believe. They published that. So different kind of Shepard moon there. Wanted to make that joke, but back to these 12 Jovian moons that they found. They put out this paper, and just for kicks, we're going to take a quick look at one of the figures there. The paper, if I can do this right, yeah, it was titled New Jupiter Satellites and Moon-Moon Collisions. So collisions of moons and moons, not collisions of moons, just totally different. So this is one of the figures of Shepard et al. From their 2018 paper by this name. But here's our Himalia group in here. You can see the circle size represents it's the logarithm of the size. So the huge spread circle is Himalia, and then there's like a bigger circle inside of another circle that makes like a smiley face with this other thing. So we have the 3 not ridiculously tiny dots. Those are the 3 that are not Dia or Ursa or Pandia. But there's our little Himalia group and where those kind of fit in all these other moon families. So you can look up that paper. Again, it's New Jupiter Satellites and Moon-Moon Collisions, Shepard et al. 2008. But the other interesting thing that they saw in that, 2 things really that they published in that paper, really short, worth a read. One, there were 2 other moons that they kind of thought they saw but then lost track of, that may have been part of the Himalia group. And but they couldn't really do follow-up because again, these things these moons, like I think the Ursa and Pangaea, those two that are not shown here because they're so relatively new, we're talking 23rd, 24th magnitude. So super duper duper faint as seen from Earth. Um, so kind of maybe some more follow up to, confirm or find a few more Jovian bodies there. The other interesting thing was that when they looked at the velocities of these moons, they they theorized that there may have been a second kind of breakup event. So possibly some kind of event to break up the asteroid when it first got captured by Jupiter and be kind of stripped apart into these bits and pieces instead of being one full body. But then looking at the velocity, they said there's a possibility that maybe there was a second event. So that's the moon-moon collisions part. So your Himalia group, some kind of interesting, dark and mysterious, and likes to collide kind of group of 7 Jovian moons, 5 shown here, two new and 2 tiny to be pictured. So that's our little tour around a little bit of Jupiter, a little bit of Jupiter's moons. Uh, Happy to take requests for more moons. If you have a favorite moon that we haven't covered yet, feel free to send those in. But thanks for joining for this little evening, another installment of Moon-topia. Again, we'll be back next month with more moons. I don't think we're going to run out of satellites anytime soon. Again, I'm Irene Pease with the Amateur Astronomers Association. We've been looking at visuals from Stellarium, which again you can find at stellarium.org, and Open Space, which you can find at openspaceproject.com. Check out the AAA website, AAA.org, for all the fun things happening. Check out our calendar and what we have going on. And follow us on the social media. All the social media things, we're at AAADOTORG. Thanks, everyone. Clear skies.